In this video, I'm going to talk about what a subset is. I am going to define the mathematical notation that is used when talking about subsets, and I will also give some examples. Let's start with the definition of a subset. A set A is a subset of a set B if every element in A is also in B. For example, let us have A be the set 2 and 7, and we'll have B be the set 1 through 10. Then A is a subset of B because anything that you see in A, 2 and 7, those are both in B. We have two different ways that we can write this symbolically. We could say that A is a subset of B by using this symbol. More technically, this symbol means proper subset, which I'll get to at some point. We can also say A is a subset of B using this symbol. For now, I am going to just use this regular subset symbol, and then I'll introduce the difference between these two. If you recall, Q is our set of rational numbers, and Z is the set of integers. Every integer is a rational number, so we can say that Z is a subset of Q. If it's not 100% clear to you why every integer is a rational number, just take any integer, maybe 47, and we know the rational numbers are anything that can be expressed as a fraction. So 47 over 1, that's the same as 47, and that is both an integer, and it is also a rational number because it can be written in the form of an integer over another integer. I can reverse this symbol. It doesn't have to always open to the right. So for example, say I had Z here again, and I wanted you to tell me the relationship between Z and the natural numbers n. The natural numbers are a subset of Z. To describe the relationship, I would use the subset symbol, but I'm going to have it open the other way. We can also write subsets as strings of relationship. What I mean by this is if we look at n, we already know that's a subset of Z, which is the integers. We know that Z is a subset of Q, which is the rational numbers. All rational numbers are real numbers. And then we know that the complex numbers contain the real numbers. So we can write a string of things like this, of relations like this, as long as all of the subset symbols are pointing in the same direction. Like I said earlier, there are two symbols for subset. We have this one, and I've been using the second one. Before I describe the difference between those, I find it easiest if I just do a quick analogy. We know the less than symbol. We can say 4 is less than 6. We also know we can say 4 is less than or equal to 6. That's also valid. We can also say 6 is less than or equal to 6, but I cannot use the regular less than symbol. I can't say 6 is less than 6. This one is wrong. This line underneath the less than sign allows for equality. When we have our subset symbols, it's a similar idea. Proper subset means a subset, but it's not equal to the other set. And the regular subset symbol means we have a subset. This allows for equality. I am allowed to say that Z is a proper subset of Q because clearly they're not equal. Q has more elements in it. I can say that Z is a subset of Q. I can say that Z is a subset of Z if I use the symbol with the line under it, the subset symbol. But what I cannot say validly is Z is a proper subset of Z. I'm going to do a few more examples with sets of numbers. So I'm going to have I think I had A be 2 and 7 before, so we'll go with that. We're going to have B, let's keep that as 1 through 10. Let C be the empty set, and it can be written either of these two ways. Let's have D be the set containing 1, 3, 5, and 7. So the first thing to observe is that the empty set is always a subset of every single other set. So C is our empty set, C is a subset of A, C is a subset of B. C is a subset of itself, C is a subset of D. Other relationships that we can glean from here. I can tell you that A is definitely a subset of B. We've already established that. However, B is not a subset of A. If we have a slash through our symbol, it usually means not. So it's similar to something like a slash meaning not equal, or in terms of elements of a set, not an element of a set. So if I put this slash through the subset symbol, this means B is not a subset of A. D is a subset of B as well. D is a subset of itself. And D is not a subset of A. One last example, let's make a last set called E. And we'll have E be the set 5, 6, 7. I'm just going to list out all of the subsets of E. So the subsets of E are, we start with the empty set. When I list these out, I usually just start with the smallest sets first. So the set containing 5, the set containing 6, the set containing 7, and then the set containing 5 and 6, 5 and 7, the set containing 6 and 7, and also the set E itself, which is the set containing 5, 6, and 7. So these are the subsets of E. We have 8 of them. And I'm pointing out that there's 8 of them because we can see that E has 3 elements and has 2 cubed subsets. So this 3 tells us how many subsets there are because we use that as the exponent on the 2. Thank you for watching, and now for your bad lip reading.
Sorry, kid, I forget your name.
Bojang Bugami.
Bogami, that's weird. Say, what is that? Flemish or French or Japanese or Anglo?
Yep.